My name is Cal O'Connor, and in our project we will be arguing that the dam should be used for peak hours production in order to avoid power outages because the fossil fuels themselves cannot keep up with demand.
Hi, I'm Simon, and our project is problem number 3, hydroelectric power. Apparently this is based on a true story of a canyon in Glen, I guess. So, my question was, how much power should be generated by the dam at 9 a.m., 11 a.m., 5 p.m., and 11 p.m.? Here's all my work. So at 9 a.m., you can see that around here, 7.5 is the peak megawatts, and you need to add 0.5, which is above the demand. It was just part of the rules. So that equaled 8, and then you have to subtract 4.5, which is always used by the fossil fuels. It's kind of like a constant. And so at the end, you get 3.5 megawatts. I'll do one more example in case you're confused. You go at 11 a.m., about 6.75 megawatts is being used. So you add 0.5 to be above the demand. That equals 7.25, and you subtract 4.5 for the fossil fuel, and you get 2.75 megawatts. And so that continues for 5 p.m. But at 11 p.m., we enter a little issue where 5.25 megawatts plus 0.5 wouldn't normally be above city rules, regulations, which states that it has to be above 6.5 megawatts or equal to. And so I added another 0.75 to be 1.25 plus 5.25 megawatts to get 6.5 right on the dot. And then you subtract the fossil fuels and you get 2 megawatts at 11 p.m.
Okay, so for question 2, how much energy does the dam need to generate each day to satisfy the Public Utility Commission requirements? We're going to split the graph up into a couple different regions. So region 1 will be the first chunk at which it operates over 6 megawatt demand hours, which is from 4 a.m. to 1 p.m., total of 9 hours. Then region 2 is from 1 p.m. to 10 p.m., another total of 9 hours. So since we don't know the actual area, or the actual equation for the curve, we're going to estimate using a triangle and just use basic area formula for a triangle, 1/2 base times height to find the area under the curve. So for region 1, it goes to a peak of about 7.75 hours, which subtract the base of 6, and you get 1.75 as the height, and then 9 as the base. Then for region 2, you're going to, goes up to about 7.5 megawatts, so you're going to use 1.5 as your height, 9 as the base again. Brings us to these equations for region 1 and region 2. Generate 7.875 and 6.75 megawatts respectively. And then just for the baseline, 6.5 megawatt hours requirement for 24 hours a day. We do 24 hours times 2 megawatts, which brings you to 48 megawatts. Add all those together and you get 62.625 megawatts per day.
Hello, my name is Zach. I'll be answering question 3. At what rate should water be let through at 9 a.m., 11 a.m., 5 p.m., and 11 p.m.? So for 2 megawatt hours to be produced, 90,000 cubic feet per water must flow through the dam. And so since we're looking for 1 megawatt per hour, we're going to divide that by 2 to get 45,000. And so at 9 a.m., 3.5 megawatts are needed. So we're going to multiply that by 45,000 to get this value right here. And then for 11 a.m., 5 p.m., and 11 p.m., a similar process, the same math is going to occur. And that's how we get all 4 of these values.
Hi, my name is Jake Teeter, and I had question number 4, which is draw a graph at which water should be let through versus time for the entire day. So as you can see, the dam will always put out a minimum of 90,000 cubic feet per hour. It increases to a maximum of 157,500 cubic feet per hour at 9 a.m. And then it decreases to until 11 a.m. To 123,750 cubic feet per hour. It then increases until 5 p.m. And increases to a rate of 135,000 cubic feet per hour. And then finally it decreases back to the minimum until 11 p.m. At 90,000 cubic feet per hour.
Hey, I'm Carter Patterson, and I got question 5. And so what I'm doing is how much water flows through the dam per day. And so essentially what we did was we broke these down into triangles. And so for the first one, we did 1/2 times 9 times 67,500, and we got that number. And then we did it the same thing here for this triangle, 1/2 times 9 times 45,000, got that number. So we added those two numbers plus the 90,000 minimum per day, and so we did 24,000 times 90,000 and got this number when we added it up.